Good day, ladies and gentlemen. Thank you for standing by, and welcome to the Tack, Coat, and Fog Seals conference call. At this time, all participants are in a listen-only mode. I would now like to turn the conference to your host, Ann Walhout. Please go ahead.
Good afternoon, everyone, and thank you for joining us today. My name is Ann Walhout, and I'm the Association Coordinator at PPRA. PPRA and FHWA have partnered together in 2020 to put on a series of webinars focusing on EMA, ERA, and ISO's products and treatments. Today's webinar will focus on tack coats and fog seals. You'll see a number of polls up on your screen, and we ask that you take a moment to answer those, and we will close them in just a minute as the presentation begins. We also encourage questions during the webinar. All attendees are on mute, but you can submit any questions through the chat function on your screen, and we will answer those at the end of the webinar as time permits. We will be offering PDHs for today's webinar upon request, so please let us know after the webinar if you would like to receive those. I'd now like to introduce today's speakers, Jason Dietz and Kevin McGumphy. Jason Dietz has worked for the FHWA for 24 years in various field engineering positions and now works with the Pavement and Materials Technical Services team at the FHWA Resource Center. Prior to joining FHWA, he worked for 5 years as a consultant on various construction projects. Jason obtained his Bachelor of Science and Master's of Science degrees in Civil Engineering from the University of Nevada. In his free time, Jason coaches his son's baseball team and enjoys hiking with his family. Our second presenter, Kevin, is the Director of Materials and Research at Associated Asphalt. Kevin has over 20 years of asphalt industry experience and has served in various capacities at Asphalt Materials, Koch Industries, Sim Materials, and Road Science. Kevin holds a Bachelor's of Science in Civil Engineering from Ohio Northern University and is working on an MBA at West Virginia University and coaches football in his spare time. Jason and Kevin, thank you again for your time today, and I will go ahead and pass it over to you, Jason.
Thank you. Before we get started, I also want to throw out we encourage folks to, if they have any questions, to please use the chat pod on the bottom left-hand corner. We'll do our best to answer some questions as we go through, but what we'll do is probably leave some of those to the end, just because some questions may be related to comments or slides that are coming down the pipe. So stay tuned as we go through. Well, as we look at some of the poll questions, we see a lot of people are going on the web by themselves, one person. Looks like, Kevin, we got a mixture of mostly beginners and intermediates. That's okay for emulsions. So looking at the familiarity of rejuvenators, we got a lot of beginners. So rejuvenators is kind of a continuous effort of folks wanting further information, and that's okay. We'll touch a little bit, but I think we have some upcoming webinars that are going to come out of PPRA with some topics of rejuvenators, so stay tuned. When it comes to track with tack, it looks like most of the folks are beginner, and that's okay. We'll talk a little bit about that. And then looking at some of the future courses, some people's comments, thin lays, fiber mat, chip seals, yes, etc. All great. Thanks to those that participated and provided their comments. I also want to mention at the last part during the evaluation section where you guys will download today's presentation, there's a flyer there that shows the past 8 months webinars that we have done, and the recordings are there, so feel free to go to them and review them for further information. With that said, let's get started. So we're here today to talk about tack coat and fog seals. I want to say I appreciate the opportunity to have this discussion with Kevin, as well as PPRA in providing this information. We'll start off by a little disclaimer and talking a little about how it was created of both Federal Highway and PPRA, and etc. Next, we'll go into the overall purpose. We're going to start off by talking about tack coats, and then we'll finish by going into the fog seals. There has been a pronounced increase of interest regarding tack coat specifications, materials, and construction practices in the past 5 to 7 years, primarily due to the following: release of the MCHRP Report 712 by Mohammed, LSU, and then as well as creating and marketing of many new reduced tracking tack coat products. That's been gaining more experience. So reasons why we're here today to learn more about it. But the overall purpose, I want to get this out and make this clear, is to improve that overall bonding of that pavement layers. If we don't get that proper application, the proper amount, we're not going to get that good bond between those pavements. Also, to decrease the stress associated with poor bond and to improve the overall pavement performance. We all talk these days about performance specs and other things that are important, and they are, but we also have to go back to the interest of knowing what a tack code is. So let's talk about some of the key factors for the tack codes for success. Condition of the existing pavement. We can never say enough. It needs to be clear from dust and dirt and debris to get that adequate tack. Many studies have been shown this, and it's very important. Tack code application rate. We're going to go into a little bit talking about what residual is and et cetera, but we need to understand that, as well as the proper distributor operation and the emulsion break and set times, understanding what that means. Next, I'd like to talk about in 2017, FHWA as well as the Asphalt Institute put on some 4-hour workshops around the country. The purpose of these workshops was to research the combined best practices and then recommend practices that we've seen across the country for tack codes. And as you can see, we started off in 2014 in Virginia, and then over the past 2 years, we went around the country, and we ended up with 47 states. With 3 states, we just couldn't work it in because of conferences that just didn't work out well for us. But we did a pretty good job, and as we went around the country, we noticed a lot of things. In talking to state engineers, state construction engineer practices, I think the one thing that was learned the most is that I always put a smile on my face is that when it came to tack codes, it was always, in talking to them, it was always like, didn't we make changes in our specs to cover that issue? And as we were doing our workshops, we found out that wasn't often the case. A lot of those specifications, they wanted to do it, but it wasn't a high priority, and that came to be a very interesting topic as we were going around the country, as well as in their plans and how it was done, and we'll talk a little bit more as we go through here today. So some of the outcomes that came out of those workshops. Federal Highway had a best practice tech brief, and at the end here, there'll be a site where you can go into for further information. There also came the development of these AASHTO specifications that weren't readily available, and here was 2 for the MP 3618, as well as the PP 9318 for material and design specs. The construction specs currently are in the works, but at least we have these 2 to get started with. And then came the NCHRP synthesis report that we're going to talk about today, because I'm not really sure many people knew much about that. And then increased application rates. Everybody was worried about putting too much tack on. So we'll talk about that, and as well as DOT specification revisions, as I mentioned before. I spent a lot of time working with state agencies on making those modifications to their specifications and getting up to speed. Next, in some additional information, going to stiffer-based asphalts. It came to our information that a lot of people were not aware that they could go to more stiffer-based asphalts when it came to tack codes. So in simple minds, it was just by changing a slow setting 1 to a slow setting 1H, or a cationic slow setting 1H. Having those stiffer-based asphalts made a difference, and it was nice to get some feedback from some of the states that made that change and said that worked really well for them, as well as verifying the calibration of the distributor. That became a very interesting topic that we found out that oftentimes distributors weren't calibrated. And, we do it for our hot mix asphalt plants. We do it for a lot of other things. We probably should be doing it for our distributors as well. Treat tack as a separate pay item was another thing that we saw versus an incidental. And then another thing that came out is we had a checklist. For those that are aware, Federal Highway has many checklists for different preservation treatments. We also incorporated another one for tack coats, and as you can see from the site shown there, for further information if you would like to see it. Moving on, we're going to spend some time talking about the synthesis the most because, like I said, I'm not sure many people are aware of it. This report came out of the 2016 annual meeting at TRB Standing Committee on Surface Requirements of Asphalt Mixtures. Many practitioners discussed the immediate need for a summary document regarding the state of the practice of tack coat specifications, materials, construction practices, and acceptance procedures. A lot of that information wasn't well known. Thus, we established this group, and I want to share with you some of the things that came out of that document. First of all, we sent out a survey, and as you can see, the states in blue, we got a very good representation of all 50 states, as well as some provinces up in Canada. When we broke down the questions, we broke it down for specifications, for pavement. We looked at tack coat materials. We had 4 questions on there, as well as the tack coat application. There was 28, and then 7 questions on the tack coat evaluation. I would be saddened if I didn't mention this, but for the courtesy of Dave Johnson and Danny Gerhardt from the Asphalt Institute, they provided a lot of, through the study, they were the representatives leading this, and they did a great job putting it all together. And I just want to say thanks for them for allowing me to put some of this information and show it to you all today. Moving on, far too frequent practices. As we see some constructions down the road, oftentimes we may see this. Is this the proper application of tack coat? Some would differ. And then we come up with what we call windrows, zebra striping. I think one of my favorites was fudge striping down the southeast. Is this the proper application? Are we going to get that proper bond? Makes one think, I don't think so. And then here's another one. Again, more windrows. Looks like some of the nozzles are spraying a little bit more in some. So we really want that triple overlap to make sure we get that proper bonding. And last but not least is the tracking. We know after we put the material down, trucks go over top of it. If we can make any kind of intention to try to keep the contractors off it while they're doing it is very important. Not to mention, put the amount of tack coat down for that period of day of what they're going to be doing the construction. If they're going to be doing more work tomorrow, try not to put the material out for that ahead of time. Do that the next morning. That way you don't run into issues of people running over it during the nighttime, and there could be some problems that may occur from that as well. Furthermore, at nighttime, often many agencies through the cities, we do a lot of nighttime construction, no difference. We see a lot of tracking, so we need to improve this. Successful tack coat. Here's one that's shown it's been milled. We get a better bonding when we go down onto a milled surface. We're getting a nice, uniform, complete, and adequate coverage. So then, let's talk about some best practices. This is online of what we're going to talk about on the tack coat. Terminology, the purpose of a tack coat, the specifications, the materials and the products, and construction practices. The first one, let's look at the definition. A tack coat is a sprayed application of an asphalt cement upon an existing asphalt or a Portland cement concrete pavement, which may or may not have been milled before an overlay or between layers of fresh asphalt concrete. So there is a difference, and oftentimes we get questions, what's the difference between a tack coat versus a prime coat? Well, a prime coat is when you spray in the material over a subbase or a base material and then putting the material over top of it. So there are differences. Moving forward, what do we mean by undiluted emulsion? That is emulsion that consists of a paving-grade asphalt, water, and an emulsified agent. When it comes to diluted, it is that emulsion with that additional water added to it. Often case, the most common is a 1-to-1 or 50-50 part undiluted emulsion with 1 part additional water. Then the next question that often is not understood is, what do we mean by residual asphalt? Well, that is that remaining asphalt after that emulsion has set. It's typically 67 to 70% of the undiluted emulsion. Furthermore, when we talk about tack coat and tack coat break and set, here are the differences. The tack coat break, that is the moment when the water separates enough from the asphalt to show a color change from that brown to the black. And the tack coat set, when that water has evaporated, leaving only the residual asphalt, and some refer to this as completely broken. Here again is just a little schematic that kind of shows those asphalt droplets that are suspended in water. Then over a period of time, they start evaporating, and then you're left with that brown material. It's breaking. That surface changes of that pH. It reduces that charge, and then it turns to black. It cures. The evaporating leads to that coalescence, and the original asphalt characteristics return. So that is overall the breaking and setting of the emulsion itself. So it leads us to our first question, our first poll question. So who is listening? Let me bring up the pod here. Poll. A broken emulsion is the remaining asphalt after emulsion has set. True or false? You got 50-50. Now it's jumping back to true. We'll leave it another minute or two, and then we'll close the poll. Broadcast the results a little bit. Looks like true is coming in. We'll end the poll. And the question is, let me read it out. A broken emulsion is that remaining asphalt after an emulsion has set. Well, that is actually false. It's the tack coat set is that remaining asphalt after the emulsion has set. So thanks for responding. Almost there, but again, that terminology plays a very important role when it comes to understanding for the tack coats. Moving on. Now let's talk a little bit about specifications and how oftentimes we see it, the verbiage in specifications for when it comes to tack coats. So let's read this. Applying the tack coat at a rate of 0.05 gallons per yard. Anybody see something wrong with this? It's missing a little additional information. Are we talking residual? Are we talking diluted? It doesn't say that. If it is undiluted emulsion, it's applied at 0.05 gallons per square yard. And using an emulsion that's of 60% residual asphalt, it leaves about 0.03 gallons per square yard on the roadway. So we're really not getting that 0.05 gallons per square yard as we originally wanted. So this is a 40% less amount that's intended. Now let's look at what if we have a diluted asphalt. That diluted emulsion would be a 1-to-1. We'll say that's, for this particular example, we'll say it's 1-to-1. And that would be 0.05 gallons per square yard. And that would leave us with a 0.05 gallons per yard on the roadway. So then with this, we're getting 70% less than what is intended. So big difference. And then lastly, to receive that residual amount at 0.05 gallons per yard, which what we're wanting to have, using an emulsion with 60% residual asphalt, the contractor would need to apply 0.083 gallons per square yard of the original emulsion. However, if he's going to use a diluted emulsion, he's going to have to put down 0.16 gallons per yard square to cover his roadway. I hope you guys found all that useful. Let's go into another poll question. What do we use tack coats for? Pull up here. Why do you use tack coats? Prevent that slippage between pavement layers, vital for structural performance, all layers working together, and apply along the transverse and longitudinal vertical surfaces. There may be more than one answer for this particular question. That's kind of a hint for you. Anyway, we broadcast the results, and then let's end the poll here. Well, the number one factor is the purpose is to promote that layer bonding. That is very important, and that is the number one reason. Yeah, we'll move on. So next, let's go talk about the consequences of poor bonding. The consequences of poor bonding, as most people will see from this crescent-shaped slippage crack shown on the photo to the right, often rapidly appears on a poorly or unbonded areas. These slippage cracks typically appear in areas of extreme stress, such as braking areas, high-speed curves, or areas where sharp turning movements occur, the type of cracking that is usually limited to local areas of high stress. It is possible for these types of cracks to develop due to excessive tack application, but the typical reason is no or low tack or properly applied tack has been tracked off the job by mixed trucks backing into the paver unit of uncured tack. A proper mill and patch operation for repairing these areas is necessary to alleviate the stresses on a properly designed pavement. So as we look at that, as we see what would be the direction of the traffic, often is the question I usually ask folks to tell. And you may have one way or the other, but oftentimes the traffic is moving in the direction of the red area. Moving on, back to the survey, when it talked about the failure types that were cited by the agencies, the number one that came in was the slippage of surface layers. The other one came in as delamination of the pavement layer. So this was kind of interesting to see the results that came out of this. Next, we also talked about shoving, and here are some photos of the shoving on the left. And then I got some pictures from Road Science that showed a core in Salt Lake City that was taken of the surface. And then within days, as you see here, look at the amount of slippage that occurred over just that period of time. This is kind of evident, kind of the showstopper of why tack is so important when it comes to bond. Moving on, the loss of fatigue life examples. Oftentimes people would like to know, okay, what are the published research analysis, the consequences of the bond and its effect on fatigue? And here are just a few the literature that came out in for May and King. This was done in 2004 for a TRD presentation. They came out and said 10% of the bond loss and with 50% less fatigue. Another one, Roth and Champagne, this was in 2002. They talked about the characteristics test on the bond test. And then the last one, Brown and Brutton. The influence of bonding between the bituminous layers is what their journal talked about, and et cetera. And they mentioned for no bond, 75% loss of life. So it makes a big difference. Moving forward, we have some photos that were provided to us from a conference that was taken at the North Central Asphalt User Producer Group meeting in 2014. And some of these photos came from Jason Blomberg from Missouri DOT. And as you can see, they have a photo here of early fatigue, 8 to 10 years on the interstate system. Well, after the fact, they took some cores, and they found out from these cores, it showed basically that there was lack of bonding for the reason for these cracks. And that's one way one can take to evaluate if there is bond or no bond as well. Okay, Kevin?
Yeah, from here I can take it to more of the characteristics of what the tack material is composed of and why the performance is important. First thing you'll see here is tack coats are generally specified by agencies using AASHTO standard protocol. You can use emulsion or binders in most states, or a combination of the two. I would caution you on this to make sure you contact your local state agency and or your local suppliers to be sure that the nomenclatures that are used are available in your state or your area. The other thing is some states will change nomenclatures and write their own version of a specification, so you'd always want to reference your state manuals. These are pretty standard. M140, M208, M316, M320, and M322 are the standard binder specs and limits. This is just a breakdown of what's being used out there from the survey that Jason referenced earlier. Straight binders are about 0.4% of the tack usage, straight binders being PG graded asphalts. Emulsions make up about 79.4%. Cutbacks really aren't used much anymore and probably shouldn't be, and for performance perspectives. And reduced tracking tacks are about 20.2% of the usage level. Breaking that down a little further, it was mentioned in the first slide that I covered here that some states will allow more than one material. This is the standard emulsions used. The SS1H non-standard would be something that the state creates on their own. It's not in the M140 or 208 spec. And then SS1H, SS1, and CSS1. And those percentages are based on the percentage of states that will allow those materials. So a lot of states will allow CSS and SS depending on what the suppliers can provide and a mixture of these things. So that's not supposed to add to 100. So I don't want you to think that it's the percentage of the states that are allowing that usage. Reduced tracking tack emulsions are something that's come up over the last probably 8 to 10 years. Tries to keep most of the tack under the pavement instead of tracking up on the wheels and the equipment on the construction site. It's a chemistry adjustment and or a penetration adjustment to the tack coats. And as you can see here, there are a few different types. 24% of the non-tracking tack used is nomenclature MTSS1HN. And then there's a bunch of different varieties, and most suppliers of emulsions have their own version of a reduced tracking tack. So I would recommend that you reach out to your local producer or supplier to get their perspective on this if you're going to use that. Material acceptance. Every agency generally has a method for material acceptance. If you are using standard AASHTO acceptance materials, you generally just have to be on a approved source list with a DOT. You get on that approved source list by doing some paperwork and submitting some samples and testing. And once you're approved source, you have to comply by a quality control program that the DOT approves for you to be able to ship materials in their state to ensure that you're providing quality on-spec material for them. Some states have supplier certifications, which is a little different, where your material meets the agency spec, and they just assume and act as if because you met the spec that you are certified to supply there. And then the testing of samples is a regiment that's under your QC plan. There are some things that are one-off type materials that we talked about that aren't standard. And in some of those instances, the supplier will produce a material that performs in the field in trial mode. Once the DOT sees the performance, the specification is shared with the DOT from the supplier, and the tests for supplier certification are then reflective of the test of the material that was trialed. So there's a handful of ways to get on this list, but in general, what the takeaway from this slide is if you're a supplier and you're on the approved list for DOT, there was a standard method to get on that approved list, and there are standard criteria for us to stay on those approved lists, which means that we're supplying on-spec quality material to the agencies that are buying it. Which leads us to how Tack's paid for. And I think this is important because for the importance of Tack that Jason talked about, you want to make sure that you're getting the right application in the proper amount and not the minimum or the maximum amount, just so that the contractor and or supplier can get paid according to the volume. So you want to really be paying for the emulsion in a manner in your specification that ensures you as the agency gets what you're asking for. If you include it in a pay item, it generally is a little more scientific in the application process, and you generally get a more accurate depiction of what you're asking for. Some places still have it incidental to paving, and when you have an incidental to paving, it's not a trackable item, so you can lose track of the application rate and the volume. So it's really important, in my opinion, and I think in most opinions of most of the states, to have it as a pay item so that you can track it and quantify it and pay for what you're getting. When you do that, there's different ways you can measure and pay. Jason talked about diluted versus undiluted emulsions. And really, diluted emulsions just have added water, because emulsions are a mixture of asphalt, water, and an emulsifier that will make those two coexist together in a brown liquid. So if you add more water, you're lowering the percent asphalt content. So when you dilute an emulsion, you've got to scale up the residual content and then scale up the application rate to get the target residual content on the road. So that's the importance of understanding how you specify and how you pay for your materials. Some places do it by volume and will charge you by the gallon. Some places do it by weight, charge you by the ton, liter, whatever the standard of practice is in that area. But that's the payment method. Is generally it's gallon or ton. And once you get it on the job site or you're storing it in a tank, emulsions can be finicky at times, and depending on the chemistry that you use and the type, some are easier to store than others. Generally, slow set emulsions will store longer and better than rapid set emulsions, and generally rapid set emulsions will store longer and better than some of the non-tracking emulsions. So depending on what you're asking for, you may want to tailor and or store things a little differently. But you always want to have insulated storage tanks. Emulsion doesn't like freezing temperatures because it's got water in it, and the colder it gets, the harder it is to pump. So insulated storage is generally a good idea. General agitation being available is also a good idea. And when we say general agitation, it could be with mixing with a mixer. That could be circulation with a pump. And in extreme cases, maybe just pulling some air through it, but I would not recommend that be a standard practice. You want to do gentle because you don't want to whip air into the system. Any air getting into the system will cause the emulsion to break prematurely, and it'll cause trouble with your spray bars and your filters and some of the other equipment and application procedures. Proper temperature range, I'd recommend you get with your supplier of your material. SSs can be probably stored and handled in the 70 to 100 F range. Rapid sets, you're probably looking more like 120 to 180, and some of the non-tracking will have very different characteristics, so you want to get with your supplier specifically on those. Avoid contamination. If you're diluting, only dilute with potable water. Don't use water from the ditch or water from the local river. Make sure it's a potable source. And then also you don't want to cross-contaminate with other grades of emulsion and or other charges of emulsion, because that'll change the characteristics and or break the emulsion in the tanker or in the distributor. That's a bad day when that happens on the job. And again, every supplier that's on an approved list should know all this. If you have questions, ask your supplier or reach out to AEMA via the website, and they can answer any questions through their technical services. Construction practices for Tack code. I think this is where I turn it back over to Jason. Is that right, Jason?
Yeah, that'll work. Thanks, Kevin. Through the survey, it also looking at the construction practices and provided some details of finding the agency's contractors' best practices. And through this, they found that training and communication is critical. The application rate of the Tack code is also important. Understanding the dilution issues is very important. Surface preparation, making sure that the surface is clean and that any kind of material processing or patching or things done prior to it, sealing all these cracks before they put that Tack coat over top of it is very key. And the asphalt distributors, making sure that the proper calibration is being applied. And then lastly, vehicle tracking of the Tack coat. So it's worth it to apply a Tack. Let's take a look at the real world. And oftentimes, something that's not usually done when we're doing the calibration. Next, through the survey, I looked at dilution, looking at the pros and cons. And as you remember at the beginning, when we talked about dilution, usually that is adding of the water into the mix. And through the survey, it looked at the agencies, and it was a fairly even split regarding whether or not they diluted it. The pros, larger liquid volumes allow easier flow, and often that was the case that we saw for most of the western parts of the country, where the areas of their pavements were a little bit of a ways from the plant. They wanted the ability to have dilution, not to mention with that water that provided them the extra time. Larger liquid volumes allow easier overlap of the fans, and often the case when a lot of these pieces of equipment were in the earlier days, not saying nowadays, but with the more advanced type of equipment that we're seeing out there, this may not be as much of an issue as it was once before. And then looking at the dilution cons, the risk of losing control of the product was the con, reducing the additional time to break, and lastly, increasing that risk of that Tack flowing on the roadway surfaces. We didn't want that to happen. Moving on through the survey, what was allowed, what wasn't, and it was pretty close to being a pretty straight split. But it came in dilution was 48% and 52% not diluted. And oftentimes we see on the undiluted, it's most of the states east of the Mississippi that really didn't have to worry about diluting it as much. So the recommendations were to verify dilution amount. Dilution cannot be used to stretch the Tack, and oftentimes as the contractor's out doing his job during the week, when it comes Thursday and Friday, if he's running a little low, you'll often see a take truck to the nearest water hole, filling up a little bit. So those are the things that we want to be on the lookout for. And also making sure with that use of putting more additional water, how that's going to affect that residual value. Getting that proper bond is important. In addition, where dilution is allowed, through our workshops, we weren't saying that states shouldn't be doing dilution, but if they are doing any kind of dilution, it was recommended that the supplier's terminal, that they have some kind of cert when that was being done. That way they have the information and they're not going to the nearest water hole, so to speak. And as you can see at the asphalt suppliers terminal, 86%, quite a big percentage there. At the contractor storage tank, 33%, and in the contractor's distributor, 48%. Moving on, the dilution verification methods, how they go about verifying the distributor. And as you can see here, some of the top ones came by certifying an asphalt supplier. Then the next one came in from sampling from the distributor. And then from there, sampling the contractor storage tank. The dilution rate is not verified. And then it's breaking down the certification by the contractor and then visual observation during dilution process. So we got quite a range there. But again, like what we were saying on the previous slide, if dilution is being done, we recommend that it be done in some kind of certification process at the supplier's terminal be used. Moving on, surface preparation. As we found that oftentimes when we're putting on our tack coats down, the surface is not totally clean. There's excess amount of dust and dirt, debris, and how that could affect that bond between that existing surface became a very important issue. So the survey asked a few questions on this. Power brooming was the most commonly used method for cleaning the roadway surface. And then in addition, they looked at using the air blowing and the vacuum. That came in at 25%. Multi-specified methods, 2%. And then clean but method not specified came in 33%. So that is an area that we probably need to do some work on in our specs to clean that act up so it's not just not specified whatsoever. Moving on, what do we mean by clean? Well, that was another question in the survey. The surface must be dry. And what do we mean by that? Oftentimes when we did our workshops, we mention SSD, surface saturated dry. It may have a little bit of moisture in, but areas of the country like Florida and that, the amount of rain that they get, to get completely dry would be impossible sometimes. So some of the things that came out of this, the goal of the surface preparation is to produce a clean and dry surface. Again, that came from the Tack coat, Tech brief. And then in addition, a small amount of moisture on the pavement surface fund should not be detrimental to that long-term Tack performance, although a damp pavement will slow the cure break time of the Tack emulsion. Another thing came out of the NCHRP report 712 that determined that for the effective water on a Tack surface, in the majority of cases, there was no statistically significant difference between wet and dry surfaces. So that was kind of nice to have and something to share. Furthermore, another important thing that doesn't get recognized as much is the application temperatures. As you can see on the very differences of the types and the grades, the rapid sets to the slow sets, and then moving down to the rapid sets to the non-tacky materials. Temperatures play a really important role. And again, if these temperatures are not met during construction and the distributor is going out at the beginning of the morning, the truck has been sitting there all night long, and he hasn't warmed up the truck enough, and he's going out there and putting the tack on a surface of the pavement, say in the fall time, the temperature's fairly somewhat maybe cold, he's not properly getting that proper temperature that he needs, and that way he's not getting the proper break and the set time, and that can cause the tracking. So this was one thing, it's personally I felt, was something that I saw was an issue that we've seen across the country that that probably needs to be inspected a little bit more, and it could probably help out a little bit when it came to tracking issues. Moving on, some of the goals to complete that uniform coverage were set, and we need to make sure, as you can see from the nozzles, are we getting that proper application? We're seeing a little bit of some windrows and things being happen, but we want to make sure that that coverage is being set by the distributor is complete. Furthermore, for the spray requirements for the distributor, have uniform nozzles. Oftentimes when these distributors come out of the manufacturer yard, they have a size 3 on some of these distributors, and oftentimes when they're putting a tack coat down, the size of those nozzles are usually another 1. So right then, they're putting a bigger nozzle down, they're putting more emulsion down onto the pavement, so that's maybe why they're turning off some of the nozzles, and that could be an issue. So we also need to make sure that they're clean. Periodically, they need to clean them out. Have that maximal angle. Oftentimes 35 degrees for each nozzle, for each valve is often recommended. Having that proper height of that spray bar, that 12 inches, which is mostly common. Having that triple overlap where we're getting that excess material to cover so we don't have the windrows, and the double overlap or emulsion streams. And then lastly, spray without overlap of the emulsion streams. So what came in the highest was cleaning those nozzles, having the uniform nozzles. They're very important. Okay, we come to our next polling question. How often is the distributor calibrated? Let's bring up this poll. Now, be honest. When do you see on your projects, how often do you think these distributors are calibrated? All right, I'll broadcast the results. Looks like, Kevin, folks are responding that looks like it's annually, and it's kind of nice to see. I'll end it. We got a few there that say never. And then we have some that say per job, but other it was not. So that was one of the questions that we wanted to get out of the survey. So let's hide that, and let's see what came out of that survey when it came to this. Hope this won't be a surprise to folks. But through the survey, how often were these distributors calibrated? Look what came in number 1. It was never. Then came other, then annually, and then per job. But oftentimes, as we found that most agencies have the bill of ladings, if they could use those bill of ladings and maybe incorporate another item in there about when the machine was calibrated, that might be a simple way of correcting that. But again, that's just a recommendation on our part that we wanted to share to folks. Moving on, distributor calibration, the methods, how they go about calibrating it. Well, there's a variety of different test methods. There's the ASTM D2995. That is somewhat the most common. Then we have some of the other ones for the mass applied calculation, the volume for the mass going to the nearest scale, weighing the truck in the morning and weighing the truck at the end. And then looking at the volume. Maybe bringing out your dipstick that's on top of the distributor. Often people don't know that, but on top of the distributor is a hole, and that the dipstick's up there where it's magnetic to the distributor. Take it out, and they just poke it in, and and then they take that measurement in the morning and in the afternoon, and that's how they calculate their volume. And then agency standard and not checked at all. So there's a variety. And through the ASTM procedures, you can see the felt pads that are being applied onto the roadway, and one can put them on and then over to construction, at the spray application, being sprayed, and then they can take whatever method they have, take those felt pieces of felt off, weigh them, and then get their understanding of what that application rate is. Moving on, who performs that calibration? It's nice to have a calibration, but who's going to perform it? Well, as it was seen here, oftentimes through the survey the contractor did. It came out 44%. The agency, 28%. Some even had independent testing firms that were doing it, as well as distributor manufacturer, and then others. So this was kind of nice to see. At least it's being done. Maybe not enough, but at least the contractors are making the push to make sure that's being done. When is traffic allowed on the tack? Often is the big issue. As I mentioned, some places in the country, they apply it maybe the night before, and then they start up the next day. But is that the best way? Oftentimes through our workshops, we recommended that it be done for that day's production. So when can traffic be allowed on it? Before the emulsion breaks. That wasn't chosen, but after the emulsion break was. After the emulsion has set. They didn't have a specific time delay. The next question was traffic not allowed on the fresh track. That counts pretty high and does not specify. So we're seeing again that many specifications, there was no specific time frequency of when traffic can be back onto the roadway. Oftentimes it came to the discretion of the RE on the project, the construction engineer making that call. And again, working with that supplier, that was the best way of doing it. Moving on, the methods to use to minimize the tracking. Here were some of the things that came from the survey. One of the biggest ones is on the bottom, tracking or pickup continues to be a problem. In addition to about the upper part, allows the use of reduced tracking, Tack materials. And again, with this non-tracking materials, that was the purpose of creating this, so they wouldn't have a track. But then there comes to an issue of what the non-tracking material would do in the colder temperatures, and studies, I think, continue to be looked at when it comes to that. But all over, these were the methods that were used to minimize the tracking. Kevin?
Yeah, go back through the testing and acceptance of Tack codes. As reiterated earlier, there's generally an approved source list for your agencies and that you will do work in or supply to. And to get on that approved source, you normally have to go through some qualified producer list procedures, which means you generally have to produce material to meet their spec, supply the DOT with a sample and a certificate of analysis for that material, get validation and verification from the DOT that their test data and your test data are statistically similar, and then you'll be put on an approved list of ships materials. From there, you'll have supplier certification of the product, which means you will submit as a supplier an agency QC plan that will be approved by the agency, and you test in accordance with that plan. As long as your materials are meeting the requirements of the DOT spec and the plan you submitted, you will be able to supply the material to contractors. And then there are acceptance testing in some states of field samples, and they're taken from distributors in general in this scenario or on-site storage tankers, and they will be tested to validate that the material meets the spec and the criteria listed in the QC plan. And then other states just have acceptance testing at the supplier where they'll periodically stop by the terminals that are shipping the material and take samples and ensure that the materials in the tanks are meeting spec. One of the big takeaways out of this slide is if you are the person and or persons that are taking these samples, generally plastic containers to keep material or the charge out of a metal container, and some things that happen between the chemistry and the charges of emulsions and metals. You would want to do plastic containers. You would want to fill them as full as you can to keep air and agitation from happening at a violent rate inside that jug as they bounce around in a car or a truck or a box or transport. And then you would want to make sure that you have good fitting lids to keep air out. The picture on the right there, that you'd be surprised how many times Gatorade bottles, coffee cans, old pretzel containers from the lunchbox of somebody, or just a container gets used that shouldn't get used, and then the material will fail, which causes confusion and claims on the job site contractor and supplier side. So the sampling containers and the sampling methods are really important. The other things that come into play from a field perspective of accepting Tack codes, you really want to make, as Jason's reiterated several times, you want to have total Tack coverage. You don't want to have strings and streamers and cornrows or anything like that. You want to have full, even coverage. So the nozzles and the application rate, the bar pressure, things like that are all very important so that you get a good application rate. You want to be able to determine the volume either by weight picks and or application rates and measurements. You want to be able to determine the mass used by using the same methods. And then there's a method for direct measurement where you would shoot over tar paper, and I think that's what that picture is depicting. There's two types of roofing paper on that. One's vertical and one's horizontal to the path of the paver. You know the area of each of those pieces of tar paper. You'll get a weight from all of that, and you can get gallon and or weight per square yard from that. And really what the ones that are perpendicular to the center line will measure is that your nozzles are all working and applying the right shot rate. And then the ones that are in the traffic pattern will be able to tell you that the application rate with the speed of the distributor is right, so that you're not getting heavy and light spots on the road. So it's pretty important to make sure your distributor's calibrated, as Jason said also. I think that's the two main things from a contractor and supplier perspective on making sure you're getting what you're paying for. And I will turn it back to Jason for field performance.
Next, they also looked at the testing and acceptance of the Tack codes and what methods are out there currently that agencies are using. They looked at laboratory or field bond strength, the laboratory testing used for product for approval, and what field testings were used to assess the quality of that field application. So some common methods for load application were the tension, shear, and torsion. Others that were non-destructive, destructive versus non-destructive, and cyclic versus monolithic. And the one here that I'm showing is one from Louisiana, the interlayer shear string tester. And wanted to share a little bit for those that may not know or what this is, but this is a simple test that basically you put your sample in, you put on a load in, and as we see, as the load's being applied, you get some kind of shear right on that side. So for further information too, is now there is an AASHTO test method, the TP 114-15, that agencies can use for this particular type of test. In addition, here's just kind of a photo showing the test apparatus that's used by West Virginia, and where they put their sample. As you can see, they have their sample put in their mold, and basically they're putting a load on it. And then as you can see in the graph, they put that load, you get a curve that comes up like this and comes back down, and then they would get their peak. One type of method. So in looking at these bonding strength tests, 9 out of 14 states conduct some type of bond strength, so not too many. But out of the ones that do, field tension testing came in the most popular. Then there was the lab tension, the field torsion, and then the lab torsion and the lab shear. So this was kind of good information for us because we knew that there were different states that were doing different things, and this kind of gave us a pretty good idea then of how other states were taking on this type of test. Next, when does your agencies perform this bond strength? On every project by special provisions for product evaluation as part of a forensic investigation where they had some failures or other. And oftentimes it wasn't on like every project, and which oftentimes probably is not something that's really needed, but it was kind of nice. It was kind of interesting to see, though, the one that came in the highest was that as part of the forensic investigation. They were having the cracks, they were having issues, so then they were looking at it, so that was a good thing. But we would like to see a more common practice if they're seeing issues with this, that it be done more often. And nowadays, with the more thinner pavements that we're putting down, we're seeing more of this delamination occurring. So having some kind of test method is a good thing to have. Furthermore, for key items for inspectors, very important as we're out there on the project. We talked a little bit about that spray bar height being 12 inches. So as an inspector agency, making sure that's how it's being done. Making sure those appropriate nozzles are being used. Are they turning off every other nozzle? Something to look for. The orientation of those nozzles, especially at the ends of the equipment. For those at the longitudinal joints, they can alter that angle to get that proper application for that longitudinal joint. So something that's important. You also want to check that application rate by the gauge in trucks. Depending on what type of distributor I have, they should be able to share with you what the application rate is. And then knowing by some kind of a thermometer on the side of a truck or using a thermal trigger device to get some kind of an idea of what that application temperature is. As I mentioned earlier, very important for that braking setting so you don't have that tracking. And then in addition, we want to collect samples. We just don't want to say, well, we trust that the track material is okay. No, go ahead and take those samples, because if something does come out wrong or something, you'll have that information to look at to further evaluate it. If it might have been a material issue. In addition, know the desired application and residual rates. They should be in your specifications, and if not, they should be in your design plans. Visually inspect that application. Are you seeing areas that are having the windrows? Are you seeing areas that's of size of $1 that you can actually see the whiteness of the rocks? They're not getting the proper application. And then verify that applications. If you're seeing issues, as Kevin mentioned, look at some kind of test that can come out and look at that volume, look at the mass, or look at the felt papers that are on the roadway to look at the ASTM procedures to really verify if it is a problem that needs to be corrected. And oftentimes we really recommend a test section early on at the beginning of the job. And if they're seeing these type of issues, they can take care of the issue right ahead of time than waiting toward the end of a project or the middle and then trying to correct the issue. Further known areas of agreement, layer bonding is vital. We know that with that proper amount of material, it is going to bond those pavement layers together. And having that homogeneous prolific surfaces all bonding together is going to give you that performance. Making sure that surface is prepared and is clean and dry to some degree. And then also milling improvements for field performance. There has been studies that show that it gives you the better reward, as well as when you're coming in there and you're doing the milling, make sure it's also when you finish that it's clean. So common tack code questions. When do we retack is often asked. Well, if that's a question, as you can see in the photo for this particular one, you're seeing a truck drive over it. So should you retack it? Shouldn't you? Well, it is highly recommended that if in doubt, retack it so you have that bondage, the proper bonding. Moving further, here is a chart that came from our workshop through the Asphalt Institute that we had some optimal application rates. And these application rates are going to vary on surface types. For brand new surfaces, you're going to have a little bit of a less amount of rate of application, a shot rate, compared to, say, a milled surface. You're going to have a little bit more. And then if it's an existing surface without, you're going to get 0.04. So keep these in mind, and then also we broke them out if you're having a dilution or an undiluted material. These are some of the ranges that we see. As you can see, they're not specific one number. There are ranges where your specification can follow, and it's really recommended that you work with your supplier and trying to get that into a range, or if you have a specification, check your specification and see what those ranges are for those different surface types. Oftentimes when we went around the country, we saw one rate for everything. And again, that's something to look at. Furthermore, areas of known agreement, application quality is vital. Making sure you have that proper rate and consistency. The distributor truck needs to be set up properly. It needs to be calibrated and verified. And it needs to be properly maintained. If you're seeing drips of oil in the back of the axle or things like that, tell that contractor that you're seeing this and see that gets corrected, because that is going to affect that roadway. And tacking of longitudinal joints, very important. as we see across the country, other longitudinal joints, we're seeing a lot of failures here. But if we can come in there and apply that proper application and Tack, at least we're taking care of this point rather than other things. And then excessive Tack is bad, yes, but oftentimes we don't often see a lot of Tack coat being applied. And if we do, then they need to make sure they take care of it by drying it out, and just get rid of some of the moisture of the water. Furthermore, Tack rate depends on the surface condition, as we mentioned. If it's fresh, if it's weathered, it's been oxidized for years and years and years, you're going to have a bigger application, raveled, or it's milled. Further research continues on field performance, field testing, bond strength, and application amounts. We're continuously seeing agencies move on this area, and that's good, because when we're dealing with performance, this is key. And then, as was mentioned by Kevin, we would like to see treat Tack as a separate pay item. There are states out there that had it as a pay item, have gone to make it a not, and now they're back to it as a separate pay item because they learned that it is important and why they should keep with it. All right, the next things we're going to talk about, we're going to dive in and talk about fog seals. Get a sip of water here. During construction, the emulsion wets the surface of the aggregate and existing binder film. As you can see here, the description of this for fog seal is just that light spray application of that diluted slow-setting emulsion without any aggregate. The purpose is to seal that aged surface, reduce the raveling, improve that lane delineation, and the cost, and again, it can vary between the part of the country that you live in, but the typical cost for this, we just said 0.12 to 0.17 dollars per square yard. And then now, as most of our preservation treatments, we want to look at what our typical treatment life is, and it's expected 1 to 2 years. And again, I want to stress that the fog seal is a good choice for adding an extra layer of protection to that asphalt surface. This seal will not compensate for more serious problems like asphalt that has experienced more than minor aggregate loss. A fog seal will also not work as a method of treating cracks or other structural issues. Fog seals should be considered a rejuvenating option, meant to offset the process of oxidation and weakening and grow the brittleness. Eventually, the aggregate will start working loose. Fog seal prevents this through the addition of that extra aggregate, asphalt. Fog seals also help to fill any tiny spaces that form between the aggregate particles as the asphalt binder ages and wears away. This ensures that the surface remains smooth. Fog seals also increase the pavement's ability to resist that water damage by reducing the amount of water that can pull onto the surface. Next, we got another polling question. What factors must be taken into consideration when deciding the appropriate emulsion to use? And we'll bring that up here. This is our last polling question. Take a minute here and which ones apply. And there may be more than just one. We'll broadcast those results. I threw that question in there on the amount of raveling on the road just to stumble a few folks, but really the major factors that are taken into consideration when deciding on appropriate emulsion is the traffic patterns, which showed high, that's good, the general climatic condition, that's good as well, and the size of aggregate used in the pavement, very important. The amount of raveling I threw in there just to get some people off guard, but it would help with the raveling, but again, it's really the traffic pattern, the general climate, and the size of the aggregates used in the pavement. Thanks for doing that. So what is the fog seal? A fog seal application considerations must penetrate the surface voids. Very important. In order to successfully do this job, a fog seal coat must be diluted enough to easily flow down into the gaps between the aggregate particles. There, the water will evaporate, leaving behind the asphalt that will help to bind the aggregate together more strongly. An excessive thick fog seal will end up sitting on the top of the aggregate, which will lead to major skid problems that we don't want to get ourselves involved in. First, the fog seal will be exposed to much more friction, which means the seal will wear away quickly and leave the aggregate as unprotected as it will begin with. Secondly, by remaining on the top of the aggregate, an overly thick fog seal will reduce the pavement's traction. This can cause dangerous and high-speed roadways, and often the reason why many state agencies haven't used it on their interstate systems. And as a loss of traction will make cars more likely to skid and lose control. So determining the ideal dilution of a fog seal requires proper knowledge and experience. And I think that's a good segue to lead right into you, Kevin. Suitable surfaces.
Okay. Suitable surfaces, really you need to go out and look at your road and make sure that the application is going to fix the issue that you have. And I think Jason has already discussed the fact that we're really trying to treat surface oxidation and aging mine graveling with this treatment. So you want to look at age dense graded pavements that have surface porosity that can receive the fog seal so it don't get on top, or you want to look at open graded HMAs that may have graveling and loss of aggregate, fine or coarse, are usually the two general types of pavements that you'd want to look for this process. If you get too dense of a surface, obviously you're not going to get much penetration with the fog, and it'll cause the residual asphalt to lay on the surface, which could cause fat spots or look like bleeding or other things. So you want to make sure that you get enough porosity in your pavement to absorb the fog seal application. Fog seal over existing chip seals. This is pretty popular and becoming more popular. As you can see on the right there, that's the chip seal with a fog seal over it. And if done correctly, it can look very much like a hot mix asphalt or coarse hot mix asphalt. So it's an aesthetically pleasing version of a chip seal, and it generally ties the fines up and does some things to reduce noise slightly and increase longevity of the structure. So really, to get a successful job, what do you need to do? Surface prep, as in anything, is important. You want to make sure the road looks clean, relatively dust-free, free of particulate matter, dead animals, things like that. The asphalt and emulsions will not stick to. Greases, oils aren't in general, just normal practice for that. Material preparation, you just want to make sure the material is at the temperature that it's that will apply smoothly. So the recommended temperature, and make sure that your bars are clean. Emulsion application rate, it will depend on the surface. So you want to make sure you talk to your supplier and or applicator, contractor, or reference your DOT spec book for the types of pavements that they have. And then there's times when you'll have to have sand blotter out there. If you got variable pavement surface conditions throughout the project, you might have to blot a few spots just to make sure and assist in the breaking of the emulsion. Site conditions, consider the site conditions are essential. Make sure you have little or no chance of rain. These are water-soluble products in most instances, so that if they get rain before they break, you could have some brown staining of the shoulders and maybe the ditch line. So you want to make sure you have good temperature and good pavement temperatures, and no chance of rain. These are just some example pictures of surface prep. Good clean road. It's got a little loss of fine, and this would be a perfect candidate. So the materials that you would generally use for these are slow-setting emulsions, either CSS or SS, depending on the area of the country that you're in. Most of them are standard AASHTO M140 spec, and they will work that way. There are some higher performing materials out there that are supplied by emulsion suppliers across the country that may have polymer modifiers or other modifiers in them that will decrease the wear and make them last longer, stay blacker longer, things like that. There are also rejuvenating emulsions that are designed to penetrate down into the surface of the pavement further and give back some of the life at the top quarter inch of binder to kind of reseal cracks and rejuvenate the binder and the surface layer. Those are supplier specific also in most cases. So if you had those issues, you would want to reach out to your local providers and talk to them about it. Check compatibility of water when you use dilutes. Not all emulsions are miscible with water. There is a miscibility test in the AASHTO T59, I believe. I think it's still T59. But if you're going to dilute a slow set emulsion, you would want to make sure that test was ran so that the water did not break the emulsion in the distributor. And then you want to dilute the emulsion no more than 24 hours before so that there's no settlement or separation. Application-wise, you want to have pre-construction meeting, understanding of the application rates, calibration of the distributor, good idea in that phase. You want to know your pump rates on your distributor, and a lot of distributors nowadays tie the pump rate to the velocity or speed of the distributor so that you're sure you're getting the right application rate in the wheel path. You also want to check the application rate across the bar. Talked about earlier for chip seal, so the calibration of the distributor is pretty much the same for fog seal and chip seal. The application rate's just different. And then you want to make sure you're getting full coverage and not wind rowing or corn rowing, depending on what part of the country you're in. They call that different things. The application rate's usually very low, considering, and the spray temperature of SSs and the CSS type emulsions are 70 to 160, so it's almost ambient. Here's a little calculation and showing emulsion, percent original emulsion dilution rate, and over a tight surface that's like a dense graded asphalt that may have some minor raveling, what your shot rates might be, and then over an open surface if you had an open graded friction course that was raveling a little bit that you wanted to kind of tie the surface up. You can see that there's a good bit of difference between the application rates that would be desired to do the same fix for both of those pavements. Another part of the application process and understanding the distributor and the calibration is your spray bar height. As you can see here, the higher the spray bar is, the wider that fan triangle becomes, which means that it will overlap or double overlap or triple overlap at different rates based on your spray bar height. The other thing that impacts is the bar pressure. So if you have high bar pressure or low bar pressure, it'll also impact the width of that fan. So you want to make sure you got a pretty constant bar pressure, a pretty constant bar height. And then the last thing that impacts it is your nozzle type. And distributor manufacturers have several different nozzle settings, and you pick the nozzle based on the viscosity and application of the material you're trying to spray. It's no different than a paint gun or any other thing that you would use around the house, yard sprayer, pressure washer, things like that. The nozzle size will impact the width of that spray. So you want to make sure you look at your distributor manual have the right nozzles for the viscosity of the material being applied. And lastly, after you have the right nozzle, you want to make sure they're set correctly. As you can see, a 90-degree setting will give you a pretty much constant stream. 45 will give you a little more of a triangular shape, and then the closer you get to 0, the wider the lateral coverage would be. So you want to set those angles so you're getting good triple overlapping action across the spray bar. And again, that should be in your manual for your distributor and your bar pressures. And I think Jason will take us home from here.
You bet. Now to wrap things up, some post-treatment procedures. Always one wants to keep sand blotter and sweeping opportunities available if necessary, because you may have some areas that are blotted a little bit more than others, and that's why we have the sand blotter to take care of those things. And as you're an agency from like this particular diagram, if this is the first time you're using fog seal, it's probably a pretty good idea to use it on a shoulder for a first application, just to get a handle on how it's going to perform and how it's going to work, making sure that you got the proper application rate and things like that before you go with the main line. In addition, the pavement should not be open to traffic until adequate friction is restored. So this is something that one needs to keep in mind, and this may take a couple trial test sections to do just to get everybody lined up to what is the best practice. I threw this in as kind of a measure of effectiveness when it comes to fog seals, and as you can see, it corrects that oxidation and that rattling. It does slow down and reduces that moisture damage, that cracking, rattling, roughness, and rutting. When it comes to preventing delays, moisture damage, rattling, rutting, and roughness. And then if there's looking at the negative effects, it really doesn't have many other than maybe possibly friction, but something to consider and think about. Now I'd like to end with just some helpful links. We have an FHWA website for checklists, like I said early on, for when we were talking about Tack code. If you go to this site here, it goes in a variety of different checklists that are available, as well as some tech briefs that we recently did through Everyday Counts 4, looking at different regions. We had 10 of them. Look at that site because it shows those regions, peer-to-peer exchanges, that talked about some issues that they're having in regards to preservation and some other types of treatment. So get a chance to check that out, as well as the Asphalt Emulsion Manufacturers Association. Here's a site where it goes in and talks about Tack code and prime code. And then lastly, the Pavement Preservation and Recycling Alliance, PPRA. There's some sections into their website if you're not familiar with it already. Take a peek at that, and if you're looking more particularly for Tack codes, there's a website there, as well as for fog seal on the bottom there. Now I'd like to give it attention to Ann. She's going to talk about our next webinar that we're going to have next month. Ann?
Yes, thank you everyone for joining us today, and thank you again to Jason and Kevin for putting together today's presentation. A copy of the recorded presentation will be sent out via email and will be posted on roadresource.org in the next few days. The next webinar in the series, which will be on slurry and micromix design and material testing, will be given by Sally Houston on November 19th. To register, you can go to roadresource.org, and we look forward to seeing everyone then. Back to you, Jason. Thanks.
Thank you, Ann. Now, as we were going, we answered a few of the questions. I want to jump into the evaluation section because we have about 4 minutes left. I apologize if we don't have the time to answer all questions, but following this webinar, Kevin and I will go through the questions that we haven't answered, and we'll make it on an additional file for folks to have for their information. So give us a couple days and we'll get that out. But I wanted to share our evaluation section because we take this very heartily about providing these web trainings that are useful for you. And if you please take a moment to go through these 7 different slides. Below the arrow, there's 2 little smaller arrows. Use the smaller right-hand arrow with a little line to go through the 7 questions, and please answer them appropriately, as well as the slides. are shown in the file share pod there. You can download them as well as upcoming and past webinars that we've had. So please take the time to do that. With that said, we got 3 minutes. Let's see what we can do to answer some people's questions. First, there's a question here, Kevin, on do we have any Tack material recommendations for PCC payments? Well,
Tack materials for PCC? Is that what the question was?
Yeah.
I would say the materials that are specified by most agencies will all work on PCC. The application rates for PCC pavements generally have to change, and they would, a good way to optimize that would be to take cores and do the shear testing that was shown in here to make sure that you're getting proper shear or proper shear resistance and with your tack code and optimizing your shot rate around that. That would be my opinion.
Well, and that's good, Kevin. And also, Jim, we give a table for recommendations, and there is a recommendation for applications on existing PCC pavements. So hopefully that answers your question. Now we'll kind of go up here. Which ones we haven't maybe asked. Thank you, Kevin, for answering most of them.
I tried when you were doing most of the presenting.
All right. Actually, we did a pretty good job. There's a question here. Were any low temperature cracking concerns with 1 hour, 1H type emulsions?
Yeah, I think I did my best to answer that, but I usually, and from a supplier's perspective, when we're making 1H or 2H or any H type emulsion, your low temperature properties for the binders are generally in the -22 range. So as long as you're not in maybe the most northern climates of the U.S. or maybe reaching up into Canada, that very likely isn't a huge issue.
And then we have a question here by Mr. Schrocken. What is the effect of set or pure tack coat on skid resistance?
Yeah, I think there was a slide in here about who lets people drive on tack. And in general, tacks aren't open to traffic. If they are, it's because of rain set in or something to that effect, and they couldn't cover it. In general, I wouldn't think that you would want to drive on the tack coat. But if you did, I think the tack coats are applied in such a low application rate that the skid value probably isn't drastically affected.
Good point. And again, that goes with the thing about applying that tack coat for about what construction that you're going to be doing for that day. It's not highly recommended that you do something for what you're going to plan on doing tomorrow, even though the contractor may not have the appropriate amount of staff, but that's something that needs to be talked about during your meetings with the contractor. Jibu, I hope we answered your question on what residual and diluted is. I think we touched on that, and I think we provide enough information on that. And I think we're good, Kevin. Thanks for doing that. Yep. So, in wrapping things up, Kevin and I want to say thank you very much for taking the time, and I hope you enjoyed the webinar today. Again, please take the time to fill out our evaluations. We use them very much so in looking at what future things we can do to make these better for y'all. So please take the time. With that, Kevin, anything you'd like to say to wrap things up?
No, just thanks for everyone's time, and appreciate the invite to be able to be a part of it.
Great. Thanks, Kevin. And then on the last slide is our contact information. Feel free to reach out to Kevin or I if you have any further questions. So with that, thanks everybody, and have a wonderful day.
Ladies and gentlemen, this concludes our conference for today. Thank you for your participation and for using AT&T conferencing services. You may now disconnect.